All right, pulleys are our last type of lever setup, and it's kind of the same concept here, where if I have a pulley, let me see if I can change my color because it'll be easier to see. Maybe this bright green. Okay, you think of your fulcrum as being the middle of your pulley here, and then you would have kind of your force acting down one side of the pulley because you have a rope going through here, and then your resistance acting on the other side. So it's kind of a setup like that. And so you can see that when I have a basic pulley like that, it's not going to do much for me, but we'll talk about how these things work in the coming slides. Okay. I have to turn this off. Sorry. There we go. One more try. There we go. Okay. Excuse me. So a fixed pulley, there are two types of pulleys, right? So what happens with a fixed pulley is it is attached to a ceiling or a floor or a wall or something like that. They don't have a good drawing here, so I'm going to draw right here. How that stuff gets drawn when they're connected to like a ceiling or something is you usually have like a beam, and then you kind of have these lines showing that it's grounded somehow. So a fixed pulley means that I'm connected to a surface of some kind, and all that's happening is I have a rope going through, and you can see that I have the weight down here, and I have 10 pounds, or I have an effort right here. And so all that happens with a fixed pulley is when I pull down, this goes up. I have 10 pounds over here. I have to pull with 10 pounds in order to make this thing move or to balance it out. So all a fixed pulley does is it changes the direction of force for me, and it gives me an IMA of exactly 1. Okay. A movable pulley is a slightly different setup. Technically, a movable pulley is a second-class lever, and that's because what happens here, so this is my surface here that's grounded again. I'll draw those lines. And so I have my fulcrum rotating right here. My weight or resistance is being applied, and it's hung from actually the middle of the pulley. So you can see the difference. This pulley right here is connected in the middle to the ceiling. This pulley right here is connected actually directly to the weight. So I have the weight connected to the pulley right here. I have my rope is connected on one end to my ceiling in this picture, and then the other end of the rope is pulling, is where I apply my effort force. So I have 10 pounds acting straight down from the center of this pulley, and then my both of my strands of rope are going to apply, they would give me a support. So I have a gear or a mechanical advantage of 2 to 1 because in pulleys it's pretty simple. You just kind of count the strands that are supporting your weight that's moving. So the force directions stay constant, and in this case, a movable pulley, if there's just one pulley here, it's always going to have a mechanical advantage of 2. That's if there's one pulley. Now there's a setup with pulleys that's a little bit different that gives you even greater mechanical advantage, and that's when you use pulleys in combination. Okay, so this is a combination of fixed pulleys and movable pulleys. What does that mean? Well, if you look at this pulley right here and this pulley right here, these are both connected on this rod directly to the ceiling. And again, they have my lines that I talked about showing that it's connected. So these are fixed pulleys. These two down here are movable pulleys. The weight, this motorcycle, is connected to a bar, and that bar is connected to both of these pulleys. Let me see if I can clear my screen again, just to make sure we're all clear. So this loop, my string is attached, kind of like it was before. In a way, it's attached directly to the ceiling, to this grounded rod, and it loops around this pulley here, and then it goes around that pulley, and down and around and up, and then back down right here. And so how you count this is a movable pulley in combination, which is called a block. Fixed and movable pulleys in combination is called a block and tackle, and they provide mechanical advantage and a change of direction for effort force. So what happens is I have this single rope threaded multiple times through a system of pulleys, and so the pulley IMA in that case for block and tackle is the number of strands that are opposing the force of the load. And so in this case, I have 1, 2, 3, 4 that are opposing the force of the load. Why is this one not counted? It's because this last one is strictly going over the top of my fixed pulley right here. And so this strand and this strand are basically the same. This is that 1-to-1 setup that we had before. So these are supporting the actual load itself, whereas this is just being pulled on. So I have 1, 2, 3, 4 that are helping to pull this motorcycle up. If somehow this was looped around one more time and I was pulling up right here, then I would be supporting the load and I actually would have a mechanical advantage of 5. That might get kind of confusing. So just worry about looking wherever your load is at. Straight above that, if I have 2 movable pulleys, well, each movable pulley is a mechanical advantage of 2-to-1. So I take 2-to-1 times 2-to-1 since I have 2 pulleys, and then I've got 1, 2, 3, 4 right there, and that's my mechanical advantage. And so that makes life pretty easy when you're talking about pulleys in combination. You just count the number of strands opposing the load when you have a block and tackle set up. Okay. And I'm going to end it there. We'll do some practice problems a little bit later in another video, so look for those.